On today's Maker Mashup, we're taking 4 webcams and 1 Raspberry Pi and turning them into IP cameras for our 3D printer. So today we're going to be taking 4 different webcams. We're going to be using a Raspberry Pi and turning them into IP cameras. And we're going to be doing this for our 3D printers. Now, you may be saying to yourself, why would I want to go ahead and do this when I can just install OctoPrint, throw a webcam in there, and be up and running? Well, the reason is because I need to display webcams from different views for different 3D printers. So I also run multiple OctoPrint instances. So for me, I would either have to have a lot of different Raspberry Pis or a lot of different instances, and I start running into problems with the USB bus not having enough bandwidth to properly handle all those webcams on one single computer. So the best way to handle this is really for me to have a dedicated IP camera. IP cameras, as you know, are pretty expensive. So if I had 4 different IP cameras, a decent one's going to cost me at least $60. You know, you've got $240 right there in IP cameras, just so that way I can monitor 3D printers. Now, with these cameras, I can get them a little bit cheaper and I can control what cameras I want to put in here. In this case, I went with mostly Logitech C920s. I did have one C270. The quality isn't as good on this one, but it gets the job done. Now, the other advantage to doing this approach is that I can control everything on the Raspberry Pi and I can control everything on my webcams. So whereas an IP camera, I may have to use proprietary software, I've got full control with the Raspberry Pi. So my goal here is to get all 4 cams set up on the Raspberry Pi, and then what I'll do in OctoPrint is simply reference the IP address of the Raspberry Pi and the appropriate webcam, and then I can place the webcams anywhere I want in relation to the 3D printers, and it doesn't affect OctoPrint whatsoever. So with this, we're going to have a lot of work today getting these cameras and Pi set up, so let's get to work. All right, so let's kick off this 1 Pi 4 cam project. The hardware requirements for this project are going to be a Raspberry Pi 3B Plus with a power supply. You can probably get away with a Raspberry Pi 3. The real issue here is that the Raspberry Pi 3B Plus takes about 30 to 35% CPU running 4 webcams, and that's only with 1 client. So if you end up having multiple clients access this, then you could end up needing at least a 3B Plus to power everything. We're going to also presume that you've got networking enabled and set up on your RaspPi, and then we're also going to presume that you have SSH access enabled, so that way we can remote administer everything. You're also going to need 4 webcams. I recommend a C920. You get nice quality images out of that. We're going to actually cover the C270 as well, so that way you can see the difference. The C920s just put a much better image out there. The price though is the difference between $20 and $40 to $45 for the C920, so it's a much larger investment, but the quality is much better. And then we're going to also talk about using these optional gooseneck mounts. I bought a few of these, and I'm going to use that for mounting my cameras right near my 3D printers. And then if you need, you're going to want to get some optional USB extension cords. Those extension cords will let you move those cams a little bit further away from the RaspPi. Now, all of the links for this is in the description. So let's talk about the software setup. We're going to download and install Mjpeg Streamer, and then we're going to view the webcams on the system, run a unit test once we get that installed, and then we're going to work on creating service files for systemd. And once we get those system files done, then we're going to copy them over to the systemd directory, and we're going to start the service and then view it in the log. So at the end goal of this is to make sure that we can enable the service for automatic startup, so that way this will start up automatically every single time you reboot the Raspberry Pi. The last step of this project is going to be to add the cam IP addresses to OctoPrint, so that way we can get a view from all the different webcams with Multicam. So we got a lot to do today, so let's get to work. So we're going to need to start by downloading the Mjpeg Streamer, and I've brought up the web page. There is two versions available out on the internet. This one is the experimental one, which has a couple of added features. This is the one that I used here in this project, so I'll have this link for this in the description. So in order for us to download this, I'm just going to copy the link of the repo here out of GitHub, and I'm going to go ahead and clone this repo locally. So I've logged in here to the Raspberry Pi, and I'm under the Pi user. You can really do this under any user, but I'm just going to use the Pi one for consistency. And we're going to just make a dev directory here. And then we're going to do a git clone, and that is the path to the repo. This is just going to cause Git to go out there and download the current version. And then we're going to need to navigate into the directories here to compile the Mjpeg Streamer. All right, once we're in here, we're going to go ahead and compile this. In order for us to compile it, the Raspberry Pi generally has this software already installed. However, if for whatever reason your version doesn't, you're going to want to go through here and just make sure that you have these libraries installed and the compiler. So the installation instructions are right here, but the Raspberry Pi already has most of this software, if not all of it. I don't remember installing anything when I ran this the first time through. So we're just going to go ahead and run make, and that's going to go forward here and compile everything. And then once this is complete, we're going to do the make install to get the software, which is going to take the webcam images, to capture it off the webcam and create a JPEG stream that the browser will use for OctoPrint, or even just directly reading it off of a web page. All right, so now that this is done compiled without any problems, we're going to do a sudo make install. And what this is going to do is put this out in the shared directories, so that way anyone on the Pi would be able to use Mjpeg Streamer, which is a good time to talk about security. This should only be run on an internal network that you trust, this software, and they put this in the directions here as well, that this should never be run on untrusted networks. So make sure that you're running this on your local network and understand those risks. So we're going to run this make install, and this will just take a second, and it's got everything installed. So at this point we have the Mjpeg Streamer software installed, and our next step is going to be to run a unit test. So to run the unit test, we need to know what commands to execute in order for Mjpeg Streamer to open up the port and stream the webcam. Now, I've done a little bit of this legwork for you. If you go to the link in the description, you'll see a cam service definition zip file. And if you download this, inside of this zip file, you're going to find the service definition files that we're going to use. Now, what you can do here is just simply copy this line out. And we're going to cover what this does in just a second, but we're going to copy this line out of the sample file, and then we're going to go into our SSH client here. And what we're going to do is we're going to look and see what video devices are available, what their names are, just to confirm that they're the same, and then we're going to run our unit test. So in order to do this, we're going to need video for Linux. So we're going to execute v4l2-ctl, and then we're going to tell it to list the devices. Now what this does is it enumerates all of the video devices available to video for Linux. And what we've got here, as you can see, are three different webcams. I have the one that lists itself as a UVC webcam. This is the C270, but the rest of these you can see are C920s. And these are all Logitech, and the links for all these cams are in the description. So now that we know what the devices are, we're going to use that line from that download, And you can see here I've already got this set up where it's set to use video 0. So in this case, it's going to go out to the C270. Now, I'm not exactly sure why it lists these twice, but the one that you want to use is the first one in this list. I think one of these may be the audio stream and one the video stream, but didn't really need to get into it in order to get this running. So the first one in the list here, so is video 0, and then we're also going to want to hook up in those service files video 4, video 2, and video 6. And these are the same each time, so what I definitely recommend doing is once you have all of the cams plugged in, go ahead and reboot your Raspberry Pi so you know how it's going to enumerate each time it reboots. So with that, we're going to cover these options here. So the way Mjpeg Streamer works is it works with an output plugin and an input plugin. And the documentation for these is included in here. And you can see it does support different input plugins and output plugins. But the ones we're going to be concerned about are the ones for UVC cameras and the ones for an HTTP stream. So in order to get this running, all that we have to do is specify the parameters. The output plugin, we're going to just tell it that the web pages for the output plugin are located in the shared directory. Now this directory you see right here is where the make install. So if you look just a little bit up, you'll see here that these HTML files were installed there. And then the next part here, you can configure yourself, but I set the ports for this at 8080. Each one of these webcams needs its own port. So it's good if you set that to video 0, so the very first one, 8080, then your next cam, 81, 82. It makes it simpler later on. And then what we're going to do is the input is just the UVC plugin, and we're telling it that the resolution is 1280 by 720. Now, the C920 does support a higher resolution. However, your USB bus does have a limit for how much data that it can stream in there. And this is the maximum that I was able to reliably get all 4 cams to work at the same time. So you lose a little bit of the resolution, but I think these pictures come out just fine. The other part is the frame rate. So we specified that we wanted 30 frames per second here. And then last parameter on here is the video device. Now you do have to make sure that you put these in quotes because you're passing these as parameters to Mjpeg Streamer directly. So once you've got that configured the way that you want it in this command line, if you press enter, you'll see that Mjpeg Streamer will start up. It may have some warning messages here about it cannot set certain values. Obviously this is not a tilt and pan camera, so those are different options that are not available. But the main key here is that we're not seeing any errors about it not having access permissions. Now, something that you may need to do is go ahead and add yourself to the video group. That would be in your Etsy groups file. So you may have to do that depending on your particular installation and access rights. I think that Pi user has that by default. So once you've got this up and running, now we can unit test this. And the way that we're going to unit test this is just open a new tab and we're going to go to cams1.local port 8080. If you press enter, you should get the HTML pages that come up. So once you have these pages up, you can see that Mjpeg Streamer is working. So let's check our cam. So if we click stream here, you should be able to see your cam. And I'm going to go ahead and move this cam a little bit. And what do you know? We've got a working webcam. So with that, we know that we've got a working webcam. Mjpeg Streamer works just fine. So really, at this point, you've got a working webcam, and the next step is just to set these up in their service definitions for us to go ahead and have this start automatically. To close this down, all you do is hit Control-C. It's going to close that thread out and be done. So let's go ahead and start setting these up as service definitions so that way the software will load automatically on each reboot. Okay, so we've moved to the dev directory we created earlier, and what we've got here is I've uploaded all of the cam.service files that are included in that zip file. Now, I've provided all these files for you, so this should be pretty much a drop-in replacement, but you do want to go ahead and validate these that they are the same. And in order to do that, you're just going to go back and run our video for Linux command again, and that's going to list out our devices. So these are our different devices. So we have video 0, video 4, video 2, video 6. And then what you're going to want to do is just go in here, edit the file, and make sure that we have 8080 and it's going to video 0. And then just do this for the rest of them. So if we add 2, 8081 and video 2, and that matches our list. And then we're going to want to do this for cam 3, video 4, 8082, and then finally cam 4, which should be video 6 and 8083. So we've got our 4 cam files, and they should all work after running our unit tests. So what we're going to do now is install these into systemd. In order to do that, you're going to need to be root, and we're going to copy the star.service files. And we're going to copy those to the SE systemd system directory. And once that's done, you should be able to list that directory. And you'll see in here we have our cam files. So they're all ready to go. We're ready to start this up as a service and take a look at our log file. All right, so with those definitions out there, we're going to want to start these services. And the first thing we need to do is tell systemd to reload everything. So we're going to do a system control and a daemon reload. So this tells system control to basically reload all of these files and make sure that they are fresh files. That will take just a second, and then we're going to be ready to start our first service. So with that, we're going to do system control, and we're going to start and cam1.service. And then to verify the service started up correctly, the next thing that we're going to want to do is take a look at the logs. So if you tail the var log messages, you'll see here that Mjpeg Streamer started up successfully. So the next step here is to just validate that the service started correctly, which it says it did. And you see we have a working webcam image. So what we're going to go ahead and do is start up the rest of these services. Now you can check in between each one to see if they started up correctly, but I already have tested this on the system, so they should start up just fine. So now what we're going to do is we're going to right click on this image, and we're going to open the image in a new tab. So you can see here we now have just the image, which is a full screen view. And this is where it is handy to have named all these similar ports. So we have 8080, so we're going to go and check the rest of our ports now. Changing this to 8081. And we've got a second webcam view different from the first. And now we're going to do 8082 and yet another webcam view. And 8083. So we're 3 for 3, and we've got 3 different webcam views. So we have a functioning system that has turned our 3 webcams into an IP cameras, and now we're going to go ahead and install that into OctoPrint and put those into the area where we're going to be able to monitor our 3D printers. Okay, so I have the cameras hooked up to the Raspberry Pi and I'm able to see all the different cameras. The next step here is to really go ahead and mount them. Now, what I'm going to do for the mounting is I've got some of these inexpensive phone mounts for your phone, and they have a gooseneck. So I can position it just about any position that I want. These run you anywhere from about $5 to $15, and I've got some links in the description below. You can also pick them up at your local big box store, and they're really great for if you take the phone portion off, the gooseneck, you can just zip tie these webcams to it, and that's what we're gonna do. Before we start doing that, take a moment and click that subscribe button so you don't miss any of my new upcoming project videos. Okay, so let's go ahead and hook these up. Okay, so I've got this one all hooked up. You can see here it's just got this big gooseneck piece, and I've got the webcam just zip tied on there, and it works really well. You can move this around, not gonna fall off, and now I can position this webcam anywhere that I want. So let's get these installed, and then we can start on our next part, which is getting this into OctoPrint. Okay, so we're in the last step here, and that's just getting this into OctoPrint. And this is the simplest part here. We're going to go into OctoPrint and click on the settings, and then we're going to go under webcam and time lapse. So this will set up the primary one, and you can see here I had this previously installed on my OctoPrint instance. I'm going to go over here to our webcam view, and this one is for the Ender 3. And I'm just going to copy that link, and then we're going to paste it in here, and a quick test, and that works perfectly. And then we need the snapshot URL as well. So I'm just going to copy the cam local portion here, and I'm going to paste it in here, and we'll test our snapshot, and that works successfully. So this is how you replace your webcam in here, and you did this when you did your initial setup. Now, there is an additional plugin that you can get and configure for additional webcams, and that is Multicam. So under Multicam, you can select multiple webcams. So we're going to set this up for the second webcam, and because these are tied to different instances of OctoPrint, I can configure each one for different printers. So I can go in here and say the C201 printer and give it that path and URL, and I'll take the endoscope out for now. So if we save this and we go to the C201 view, now we can see the other printer. So it's a good way to switch back and forth, and you can have multiple printers here. So we'll set the defaults up for these where we're looking at the default printer for this instance, but then I can view the other printers here at a glance. All right, so you can see we got OctoPrint all set up now. We've got all of our webcams, and I think it's a pretty good project because now I've got a view of various locations with my 3D printer, and I've got the ability to move these cameras around anywhere that I want and use this as a project that I can add more of these. So if I want to go to 8 webcams, I just do this project again, and I've got a completely separate device, allowing me to really have an infinite expansion of IP cameras. All right, well, that's it for this video. If you enjoyed it, make sure you mash that like button, and don't forget to subscribe and click that bell so you get notified when we release a new video. And we've got a lot of upcoming projects this year, so I'm pretty excited about the upcoming year. And don't forget to check out our Discord channel. We've got this entire chat that's a big open makerspace that allows you to communicate with other makers and get help on a lot of these different projects. And you can also follow us on Twitter. And if you are interested in helping support the channel, there's always our Patreon, and links are below that contain everything. So thanks again for watching, and we'll see you next time.